This is a big one today, Simplex Algorithm, so it kind of sucks that there's a couple of people away. But that's their concern, not mine. So far, we've seen that a simplex is a region that has all possible solutions. So let me remind you what we have done so far was, that's all we have done so far. We've coloured in an area that has possible solutions, okay? But do you agree if that's my region of solutions, would there be an infinite number of solutions? That cloud goes on forever, okay? So we would never ask you a question like that for a time-limited test. So what we are talking about today is, that's the wrong one. At our level of maths, what we're trying to do is something like in the real world, we often want to find the best or the optimal solution that meets a particular objective. So the first notes that I'd like you to get today, at our level of maths, the only optimal solution we're looking at is either a maximum or a minimum. And it depends on the objective we're aiming for. So, I don't know, if the question involved making a profit, if my business was making a profit, what would I want to do with that? Would I want to minimize my profit or maximize it? I'd want to maximize it. If the objective of the question was costs, like it's going to cost me, would I want to maximize the costs to me or minimize it? Minimize. So we're only dealing at year 12 with maximizing or minimizing. The objective in this topic is represented by another linear expression in the scenario. We call this the objective function. If that doesn't vibe with you right now, that is fine. When we do an example, you'll see what the objective function is and why it's important. You can write it in terms of the x and y variables in the scenario. Can you get those 2 points down because they're relevant for the big chunk of stuff that we're doing? So this process we're about to embark on is known as the Simplex Algorithm. People that do programming, you'd know what an algorithm is. It's a set of steps that you do repeatedly until you achieve something. So the Simplex Algorithm in our situation is a set of steps we use to define the simplex. That's what you've been doing in your exercises so far. You've just been colouring in the simplex, but now we're doing something with it. We define the simplex and then we find the optimal solution for a particular objective. This red is not notes. This is for me to tell you so I can go back to it and show you that I wasn't lying. This is a very long process at the beginning. It's going to take us a long time to do the first question, but because I want to show it and I want to have a video for the people away. It's also basically what we do for the rest of this topic with slight changes. So get good and get fast at performing this whole set of steps, and this topic takes care of itself, okay? So once again, I warn you, it starts off slow, but we get faster at it. So let's get on to those steps. The simplex algorithm, the key point of the simplex algorithm is that the optimal solution always occurs at a vertex. This means you can ignore feasible solutions that are not at vertices. So say again, the simplex algorithm, the key point of this is that the optimal solution, your max or your min, is always going to happen at a corner. I'm going to call back to that picture that I had before. So if you're writing, just pause for a second. Here, there is an infinite number of solutions. That's impossible for you to answer. But the simplex algorithm is telling you that the best solution is always going to happen at a corner, at a corner, at a corner, at a corner. I don't have to check infinity number of points. I only have to check 1, 2, 3, 4 of them. The best solution will be at one of those 4. Is that possible to check 4? It's possible to check 4 if they're the best. It's not possible to check this giant cloud of infinity solutions, okay? So that's the key point of the simplex algorithm. How do we do the simplex algorithm? Please get these steps. I'll talk you through them. Steps: decide on the 2 variables in the scenario. These will be x and y. Construct the constraints in the scenario and write them in general form. What did we do on Friday? We practiced using a table to draw the constraints. Step 3 is the reason why this algorithm takes a long time. You have to sketch it. You have to draw your constraints, all those lines. You need to color them in. You need to label the axes, label the lines, all the corners. These are all worth marks. So your graph itself is going to be worth 5. Maybe close that door because there's young children and they might start barking. So right now, all this 1 to 3 is no different to what you've been doing so far. We're preparing for this. What's different is 4 and 5.
Sorry, I'm just dropping off there.
Okay,
All right.
So say again, steps 1, 2, and 3. If you've been doing the timeline exercises, you have been doing that already. What is new? Step 4, you need to make a little table off to the side. We call it the vertex objective function table. It contains the vertex, the corners of your simplex, and then space on the other side for the objective function. Get step 4 down, please. Lastly, step 5. This will only become clear what we're talking about when we actually do a scenario, an example. But step 5, you're finding the optimal solution in the table according to the objective. State your answer in sentence form. So you need to write your answer in words, otherwise you lose a mark. Get those steps down, please. If you're a little ahead, start getting the example using Hano, who's trying to get jacked. I'm sorry, my bad. I didn't change all the names. Sorry, steps. What I'll do is I'll stop for a full 5 minutes to get those steps down. And can you please you need the steps on there and the example. So I'm just going to leave you alone until 1:15. You can talk, just no names. Don't swear. Get that example and those steps down. The majority of your questions in the upcoming test are like this. 3 more minutes. One more minute and then I'll start going through the whole process, showing you these steps. Alright, let's smash this out. 2 supplements. Power Boost, Super Health. They're used by Hano to get jacked. Power Boost contains 30 grams of carbs. Anything with numbers is relevant. 30 grams of protein. 100 grams of vitamins. The other one, Super Health, has 10 grams of carbs. 30 grams protein. 200 grams of vitamins. Each week, Hano must consume at least. Is at least an important word in our context? Yeah. Because we need to decide if it's greater than or equal to or less than. At least means greater than or equal to. At most means less than or equal to. So at least 170 grams of carbs. At least 1,400 grams of vitamins. But no more than. That's a completely different direction for the inequality. No more than 330 grams of protein. Tins of Power Boost cost $5 each. Tins of Super Health cost $3 each. Money's a bit tight for Hano, so he wants to satisfy his dietary requirements. While, are we maximizing here or are we minimizing? Minimize. The question will tell you, okay? We're trying to minimize the costs. That is my objective here. So, find the optimal combination of tins of Power Boost and Super Health. And how much that's going to cost him, the lowest amount. How much carbs, protein, and vitamins is Hano going to get with that best combo? So this, what I'm demonstrating now, is how to apply those 5 steps. So step 1, decide what the 2 variables are in the scenario. X is going to be the number of tins of Power Boost. Y is going to be the number of tins of Super Health. You do not need to, but I recommend. There was a friggin' exercise I asked you to do. I wouldn't ask you to do the exercise if I didn't think it was useful, tabulating it. Because when I helped people on Friday, you saw, when you put it in a table, it made it nice to do the constraints. So I'd suggest that. So you've got variable X and Y. Look at the question. Carbs. How many grams of carbs are there in the Power Boost tin? 30. So carbs for X is going to be 30. How many grams of carbs in Super Health? 10. And what is the constraint for carbohydrates in Hano's diet? He needs to have at least what?
170.
Good. So what inequality is at least? Is it greater than or equal to, or is it less than or equal to?
Greater.
Good. I want at the minimum this. I can do more. So greater than or equal to 170. Good. Let's do the same for the protein constraint. How much grams of protein are there in Power Boost? 30. See why the table is useful? You just look down. How many grams of protein are in Super Health? Same. Careful now. There's a different constraint for protein. It's 330, but it says no more than. So am I greater than or equal to 330 or less than or equal to? Less than or equal to 330. If you have too much protein, you get little these little nodules appear in your eye. Okay? You can't have too much. All right? And vitamins, or if you're English, vitamins, 100 grams, 200. What do we got here? What direction is the inequality for vitamins? At least 1400 grams. So greater than or equal to or less than or equal to?
Greater than.
Greater than or equal to. Greater than or equal to 1400. I'm going to chuck my money in here as well. 5 and 3. But see how it doesn't say there's no limitation on cost. We're just trying to minimize the cost. Okay? So what are my constraints? What was the point of that table? So I can draw this. Carbs is going to be 30x plus 10y is greater than or equal to 170. Protein is going to be 30x plus 30y less than or equal to 330. And vitamins, 100x plus 200y greater than or equal to 1400. So what steps have we done so far? Have we constructed those constraints? Are they written in general form? They're ready to be drawn now. Okay, so can I give you like a minute or so to get to this stage? Because we need to spend some time drawing. I'm not apologizing for this taking a while because I'm demoing every step that I'm expecting you to do. Your exercises are there to try to get you faster at it, okay? You're not, when you're doing the test questions, not sitting there waiting for other people to write. You're not waiting for me to read the question out. You're just doing it, okay? What I might do is I'll scroll down and I'll start doing the working out for drawing these. Because what form are those lines in? Are they in slope-intercept or are they in general form? General form. Can you remind me, how do I draw lines in general form? What's the steps to do that? What do I make y equals? What do I make x equals? Yeah, that's right. To make them, to find the location. So 30x equals 170. So x is going to be not the nicest number, but we'll make do. 170 divided by 30, 5.67. Y is going to be 10y is 170, so y is going to be 17. That's for carbs. Let's do protein. Protein, 30x equals 330. So x is going to be 330 divided by 30, 11. And y is going to be 30y equals 330. That one's going to be 11. That's two lines right now. My third line, vitamins. 100x equals 1400. So x is going to be 14. 200y equals 1400. So y is going to be 7. That is my working out to draw these lines. Can you have some time to copy that down too? So again, this part, this is just what you've been practicing. This is nothing new. The only new today is finding the best solution. Let me draw these. Carbs is x is 5.67. So 5.67, 5 2/3. And y is 17. Draw a line between those. This is the carbs line. Please label it. So that one was 30x plus 10y equals 170. Protein is 11 to 11. So dot here, draw a line. This line was 30x plus 30y equals 330. What's the last line? X is 14, y is 7. Draw a line. What line is that representing? That is 100x plus 200y equals 1400. Okay, so at this point, your graph should look like that. Anyone remember off the top of their head, was it Power Boost that was X or was it Super Health that was A? Power Boost, yeah. So Power Boost is on the X-axis. Power Boost tins. And Y-axis, that's worth marks 2. Please don't forget to label. Y-axis is Super Health tins. I've got 3 lines here, but can I colour them in yet? Have I decided what direction I'm going to colour? Look back at the constraint. Carbs, greater than. Carbs is greater than, so I need to colour to the right and above that line there. Protein, less than. So I need to colour under that. So I need to colour below that diagonal line. And then the other one was greater than or equal to 1400. There. I'm missing some constraints though because the tins of Power Boost have to exist. So what's my defaults as well? X must be greater than or equal to 0. Y must also be greater than or equal to 0. So I can color my stuff now. There is one shape on this set of lines that I can color in that is beneath this line, but above this and above this one. What shape would that be? There's one shape on here that meets the direction of all those arrows. Maybe it'll be easier to see if I shifted where these arrows sit. I need to colour in above this line and I need to colour in above that line too. What shape would I be colouring in now that I can see all my arrows together? Is there a little triangle in there? That's my area of possible solutions. There. But according to the algorithm, I don't need to check all of the dots inside. I just need to check the corners. There's only 3 corners in a freaking triangle, yeah? So this is 3, 8. This one is 4, 5. And this corner is 8, 3. Make sure you label that. That's the labeling done, okay? Again, this is still no different to the exercises that I've asked you to do up to today. The difference comes now, okay? The difference comes with the table. So we need to have a table that has vertex. We need to have objective function. What was my objective? I was trying to minimize the cost. Do you remember off the top of your head how much the Power Boost was? $5. So if I'm buying 1 tin of Power Boost, how much is it going to cost me? 5. If I'm buying 2 of them, 10. So what is the algebra for the cost of Power Boost? 5 times by whatever X is, because X is how many I'm buying. What would the cost of Super Health be? 3Y. And so all I'm doing with this table is running these 3 vertices, 3, 8, 4, 5, and 8.3 into that objective function there and see which one is the lowest cost. So 3, 8 is going to be 5 lots of 3 plus 3 lots of 8. What's 5 times 3? 15 plus 24. That's going to be 39. If Hano bought 3 Power Boost and 8 Super Health, it would cost him $39. But I haven't checked the other two yet, so I need to check the other two. 5 lots of 4 plus 3 lots of 5 equals 5 times 4 is $20 plus 15. What's that going to cost? $35. That's cheaper. I still haven't checked one. I've still got the other corner to check. So 5 lots of 8 plus 3 lots of 3. 5 times 8 is 40 plus 9. That's more expensive. So according to our little table here, which is the best solution for Hano to meet his requirements, but is also the cheapest, yes? The middle one. 4 of Power Boost, 5 of Super Health. So put a star next to that. You're not done yet. You'll lose a mark if that's all you did, because you need to answer the question in words. A, find the optimal solution, optimal combination of tins. Therefore, Hano should buy 4 tins Power Boost, 5 tins Super Health at, how much did that cost him? $35. Full marks now, okay? Can I give you some time to get that table down and that? That is the answer to A. We haven't answered B yet, but I'll give you time to get that down for now. So I told you it's a long process, but you can get faster at it. Couple of minutes, please. It'll take a while for this video to upload because it's so long. Question?
Is it bad that every single time I see the greater than us and I keep thinking about the crocodile wanting to eat the bigger number?
That's how I was taught.
Yeah.
We were taught it was a bird or something at primary school, how to remember.
I remember it being the crocodile wants the bigger number.
Yeah, you could argue that. Whatever works for you. I'm not going to teach you either way. If you remember it, doing that,
Yeah.
yes, good. Okay, how do we answer B? How much carbs, protein, and vitamins does Hano get with the optimal combination? Well, we have the constraints here. This is going to tell us how much. So copy. Right? These don't refer to anything right now because we don't know what X is. But have we just determined the best solution for him? 4 and 5?
Yep.
So plug that into this. Replace the X with 4 and 5. 4, 5. What's that going to be? 30 times 4. It's going to be an equal sign now. 30 times 4 is going to be 120 plus 50. He's going to get 170 grams of carbs with the optimal solution. Replace. 30 times by 4 plus 30 times by 5. 30 times by 4, 120 plus 150. He's going to get 270 grams of protein, so that didn't exceed his maximum. Maximum was 330, right? So he got 270 with that, and vitamins 4 and 5. 100 times 4, 400 plus 1,000, 1,400 grams of vitamins. Call back to the constraints that he had. Carbs. Did he meet the 170? He got at least 170, didn't he? By getting 4 and 5. Did he get less than 330? 270, that's what he got. And did he get exactly what he needed for vitamins? So that's what this process is about, okay? You're not going to have time to practice all of them in your lesson today, but I'm only asking you to do 2. That is the simplex algorithm. And no word of a lie, you're just doing that over and over again for the remainder of this topic. Try to get fast at it. Obviously, you can see that took a while, but we had to wait for you to write. We had to wait for me to read everything out. I'm telling you stupid jokes and everything in between. But if you just go, okay, it's a simplex algorithm question, and you go, draw, color, label, table, you get faster at it, okay? Just, what is it, the kids say trust or something? Trust. 2C.1, practice that.